Let's begin then. So like I said, we're going to do conclusions we can draw from a diagram. So the first picture that we see here, we can actually draw conclusions from, is going to be a picture that has that bow tie-like look to it. We talked about what we can add to a picture like this. So word-wise, what can we add to a picture like this? Vertical angles. So on the left-hand margin here, we're going to write vertical angles. So in this box, we're going to put vertical angles, because vertical angles are something that we can add to a picture. Okay, so since yesterday was Halloween, let's give this diagram here some vertices. So let's name it witch. So we got W-I-T-C-H. So again, notice I have two triangles in this picture. Okay, I have this top triangle here, and I also have this bottom triangle here. So if I name it with 3 letters, what are my vertical angles that are congruent in this picture with 3 letters? Okay, so angle WTI is congruent to, what's the other angle? Say that again. CTH. Okay, or HTC, whichever you prefer. Now, my reason, if this is something I add to a picture in a proof, the reason that I'm going to put why these angles are congruent is something like this. So I'm going to just use a different color so it doesn't mesh together here. So I'm going to put, if 2 angles, remember that's my symbol for angles, are vertical, I'm going to abbreviate vertical as VERT, then they are congruent. And again, I'm going to use the symbol for congruent. So again, my reason is going to be if 2 angles are vertical, then they are congruent. The reason we're going through this again is because today, when we're finished with this, we're going to start writing some proofs.
Today?
Yes.
What did you say you were doing?
When we're finished with this, we're going to write our own proofs. Proofs, yes. Proofs are a big part of geometry.
Okay.
Okay, so again, anytime you add vertical angles to the picture and you want to state that they are congruent, when you provide a reason, this is what you're going to write. If 2 angles are vertical, then they are congruent. Trying to slowly step through this. Okay, like I said, you're going to be supplying reasons today. There's a reasons column. If it was given to you, you're going to state it was given. But again, if you had to add vertical angles to the picture, you have to supply a reason. Your reason is going to be, again, if 2 angles are vertical, then they are congruent. Okay, so we're going to look at the second one. Okay. So I'm going to scroll down here so we can see the second one. There we go. So we got the second and the third one on the same screen here, and that's fine. Okay, so the second picture is one where the 2 triangles butt up against each other. So we're going to call this particular picture the shared side. These 2 triangles share a side. If you look at the 2 triangles in the picture, there's one triangle there in green, and just to have a different color here, here's the other triangle there in red. So again, notice these 2 triangles butt up against each other. They share a side, the side down the middle. Okay, somebody give me a school-appropriate 4-letter word.
Door. D-O-O-R.
Okay, but we can't do 2 letters at the same, 2 O's. Does that make sense? Huh?
Duck.
Duck? Okay.
What?
So we'll say the top one is D-U-C-K. Okay, so if I want to add the segment that they share to the problem, and I maybe need this to prove the triangle's congruent. Let's say we had to add that marking. Okay, statement-wise, what we would write on our paper is that segment DC is congruent to segment DC. And the reason that I was able to add this to the picture or write it within my proof is going to be the reflexive property. This is a property that you should hopefully remember from Algebra 1. Reflexive property says like x is equal to x, or 2 is equal to 2. So if we say a segment is congruent to itself, they butt up against each other, they share a side, then again my reason is going to be the reflexive property. Okay. Now the last one we're going to look at, instead of a shared side, we saw some of them in some of those pictures that had a shared angle. So the last picture is going to be two triangles that have a shared angle. These, again, come from your overlapping triangles. So in this picture, one of your triangles would be like this one there in green, and the other triangle could be like this one here in purple. They overlap. Okay, so if I'm trying to think of a 1, 2, 3, 4, 5 letter word, if I think back to Halloween, did anybody get a lot of candy last night?
No.
Hand out candy?
I went to bed at 7:30.
Okay, so we're going to name this Candy. Candy. So if I'm talking about the shared angle in both triangles, if I'm looking at both the green and the purple triangle, is going to be this angle here at C. That angle there at C is in both triangles. That's something that we've talked about. I talked to some students about when I was walking around the room. If they share an angle, you can say it's congruent to itself. So different ways you can name this. You could say that angle C is congruent to angle C, or since there's only one angle at C, you can actually just name it C. Or if I'm going to name it with 3 letters, I might state that angle YCN is congruent, that would be the angle of the green triangle, is congruent to angle ACD. That's the angle in the purple triangle. It's both angle C, because notice, C is your middle letter, C is your vertex. And this reason is the same as the one as above. This is still the reflexive property. So again, the reason we're going through this now is because we talked about before, what could you add to a picture? If it wasn't already stated, you could add any of these things to the picture. We didn't talk about how you would formally write the reason, because at that point we weren't ready to formally write the proofs. But at this point, like I said, we've been slowly taking steps toward writing our own proof. We're at the point now where we should be able to begin that. Honestly, some of you probably could have handled it early on. It just depends on the person.